Lesson 3-7, Functions and Graphs. Today's lesson, the main idea is to be able to graph data and to be able to demonstrate the relationships of that data. There's one vocabulary word, linear equations. Here's our first question. It says the table shows temperatures in Celsius and the corresponding temperatures in Fahrenheit. Make a graph of the data to show the relationship between Celsius and Fahrenheit. So the thing that we have to do here is we have to make a graph. And over here we have a table showing in the left-hand column temperatures in Celsius, and in the right-hand column temperatures in Fahrenheit. So for example, when it's 5 degrees Celsius, it's 41 degrees Fahrenheit. When it's 10 degrees Celsius, it's 50 degrees Fahrenheit, and so on. So we need to make a table, we need to make a graph of this data. I'm going to quickly explain the difference between the words table and graph. A lot of people use them interchangeably, but they actually don't mean the same thing. This over here is a table. You have columns and tables. You have data listed in columns in a table. We're over here on this piece of graph paper. We're going to make a graph. A graph has an a line representing the x-axis and a line representing the y-axis, and we have a scale, and we label our x and y axis, and that's a graph. So this is a table, and over here we're going to make a graph of this data. So in order to go about making this table, one of the first things that we need to do is draw the x and y axis. So I'm going to draw a line here, and I'm going to draw a line going up this way. And I know that I'm going to put my Celsius data down here on the x-axis because it's listed first in our table, so that's going to be our x data. So this is Celsius down here. And this over here is going to be Fahrenheit. So one of the things that we need to figure out is on the x-axis here, we have the numbers between 5 and 30. So we need to be able to fit the numbers between 5 and 30 here on our graph. Now we're always going to start here at 0. So this is 0 here. So it looks like we have enough lines here to be able to count by 5s. So if this is going to be 0, this is going to be 5, and this is going to, I'll label this one 10. This one's going to be 15, and this one's going to be 20. This one's going to be 25. So right here, this is going to be 30. Notice you don't have to label every single number. You just have to label some of them so you know where the other numbers are going to be. Here we have to go from 40, it looks like 41 is our biggest number, and 41 is our smallest number, and 86 is our biggest number. So maybe on this axis, we could count by tens. So if this is 0, this is going to be 10. This is going to be 20, so this is going to be 30. This is going to be 40, so this would be 50, 60, 70, 80, 90. And now I've made my graph big enough. Now you could choose to count by different numbers if you wanted here, but that's what I chose to count by. So what we're going to do is we're going to graph these 2 points like they're coordinates. So I'm going to graph 5 and 41. So I'm going to go over 5 on the Celsius scale, and I'm going to go 41 on the Fahrenheit scale. So this is 40 right here. So 41 is going to be up just a little bit right there. Our next one is 10 and 50. So here's 10 here, and 50 is going to be right there. Now we have 20 and 68. 20 is here, so 68 is going to be just a little bit below 70. We have 25 and 77, so here's 25. 77 is going to be just a little bit before 80. And the last one is 30 and 86. Here's 30, and 86 is going to be, if 80 is here, 86 is going to be right about there. And now we've made a graph showing the relationship between Celsius and Fahrenheit. Our next question is going to be a little bit different. Here we're given an equation. We're told that y equals 2x plus 1, and we have to graph it. Well, this one doesn't give us a nice table of data like this one did over here for us to simply graph. Here, we're just given an equation. So here's how you go about doing this. What you do is we're going to make a table ourselves. I'm going to say x is going to go here. I'm going to put 2x plus 1 there. And I'm going to put y here. And then I'm going to put x, comma, y in the last column. And here's how this works. What you do is, since this equation is set up so it says y equals, one of the simplest ways for us to go about finding numbers in order to be able to graph this is to pick any number we want and substitute it in for x. And whatever value we substitute in for x, we then go and solve this side of the equation, and that'll tell us what y is equal to. So you pick a value for x, you substitute it in, you solve, and it tells you what y is going to equal. And then we're going to get our set of ordered pairs over here in the end. One of my hints that I usually give to students about this is pick small numbers for the value of x, because you don't want them going way off your graph over here. Pick small numbers, 0, 1, -1, 2, -2. Numbers like that. Those are good numbers to pick. The other thing is, we usually want to substitute a number in for x at least 3 times, because we can do this twice and we'd have 2 sets of ordered pairs here, and you can always draw a line between 2 sets of ordered pairs, but we don't know if they're right. By graphing a third set of ordered pairs or substituting in a third number for x and solving for y, that third one will tell us if our first 2 are right or wrong, because if we have a 1 dot that's way off in one over here, let's say, and we have 2 other dots here, then we probably have an idea that one of those sets of ordered pairs is wrong. So let's go about doing this. I'm going to pick the number 0 first for x. So that means we'll have 2 times 0 plus 1. And 2 times 0 is 0 plus 1 is 1. So that means our ordered pair is 0, 1. Now let's try 1. 2 times 1 plus 1. 2 times 1 is 2 plus 1 is 3. So it's going to be 1 and 3. And the last one I'm going to do is -1. So 2, -1 plus 1. 2 times -1 is -2 plus 1 is, -2 plus 1 is going to be -1. So -1 and 1. And so now I'm going to go and I'm going to graph these numbers right here over here. So the first one is 0, 1, so that means I'm not going to go to the left or the right any, and I'm just going to go up 1. The next one is 1, 3, so I'm going to go over 1 and up 3. 1, 2, 3. Our last one is -1, -1, so that means I'm going to go over 1 and down 1. And notice that this looks like it's turning out to be a line, and whenever we see an equation kind of written like this, we know that's going to be a line. This is known as a linear equation, because this equation right here ends up graphing something that looks like a line. Because if I connect these dots, if I had a ruler, it would have come out a little better, but notice if I connect these dots, notice that it comes out to be a straight line. So this is known as a linear equation. Linear is another word for line, and this is an equation. So it's an equation that makes a line. And that's all there is to graphing when we're given some sort of linear equation. You pick a number, you substitute it in for the variable on this side, and then you solve and you figure out what this number is over here. And remember, you want to do at least 3 of those so that we check to make sure that it forms a nice straight line.